Hey everybody, it's Miss Moran and I'm here to talk to you about measurement conversions that we're going to be doing for 2 weeks, working with customary units and metric units for length, capacity, and weight. We're going to spend a little bit of time talking about references for these. You know, what does a foot look like? What does an inch look like? What does a pound feel like? But we're not really going to be spending a lot of time on actually measuring things. We're really going to be doing more mathematic calculations using them. Of course, it's important for American citizens to know these things. You know, you should know that 1 foot is 12 inches. But for our purposes, for our work in class, for our chapter test, and for our state test, students do not have to have all of these memorized. So they will get this reference sheet. It looks just like this. This is the one we'll use in class. And it's also one that they'll be used for our state test. So here we're listed the customary conversions students are expected to be able to work with. It doesn't say what these go with, so students do have to know that these are your measures for length. This is capacity, and this is weight. On the metric side, again, length, capacity, and weight or mass. Again, not every one of the conversions that they're going to need is on here, but enough are going to be on here that they'll be able to answer this. For example, I have 1 foot is equal to 12 inches, 1 yard is equal to 3 feet. I don't have how many inches are in a yard here, but students could figure out that if 1 foot is 12 inches and there are 3 feet in a yard, 36 inches would be in a yard. So there are some things that they might have to apply a little bit of extra understanding to be able to do. There's a few more down here too. Units of time, most students are pretty good with those. And then also these formulas we're going to be working with are area and perimeter formulas. Those are going to come up later. Basically all of this over our next 2 units of measurement will be given to the students. Now they have to know how to use this, and that's what we're going to be spending most of our time doing. So I'm going to start with the customary units, what we use here in the United States, and show you what students will be expected to be able to do. All right, so knowing, and I just mentioned this, how many feet or how many inches there are in 3 feet. So all of these measures we're going to be doing involve going from a larger unit to a smaller unit. So when you go from a larger unit to a smaller unit, you need more of those smaller units in order to equal the larger unit, which means bigger numbers use multiplication. So we're going to be multiplying here. But the tough part for kids is they don't know what to multiply. They see a 3 and they say, well, what do I multiply? So we're going to ask ourselves, by focusing on the unit, how many inches are there in a foot? I come over to my reference sheet and I see 12 inches in a foot. So the math problem I'm going to be doing there is 3 times 12. If there's 12 inches in 1 foot, 3 of them would be 3 times 12 is 36. Okay, for 5 yards, how many feet is that? Again, my question is to focus on these units. How many feet are in a yard? There are 3 feet in a yard. 5 times 3 would be 15. 15 feet would be 5 yards. All right, now yards to inches. Again, yards to inches is not on here. I've got feet to inches and yards to feet. So I'm going to have to do a couple steps here. I'm going to have to know that 1 yard is equal to 3 feet. And I'm going to have to know that 3 feet is equal to 3 times 12 is equal to 36 inches. So the number of yards that are going to be in 2 of those, if there are 36 inches in 1 yard, 36 times 2, it's going to be 72 inches are going to be in 2 yards. All right, and another one we'd have to do here is working with half of a foot. So 4.5 feet, how many inches is that? So how many inches are there in a foot? There's 12. Most students will want to do 4 times 12. Say 48, and just call it 48.5. That's not what we want to do. This is half of a foot. So if 1 foot is 12 inches, then half of a foot is going to be 6 inches. So really we want to take that 48, and we want to add 48 plus 6 and get 54 inches. 54 inches would be in 4.5 feet. All right, and then we'll work with some capacity units here. How many cups are there in 3 pints? Well, I have to know how many cups there are in a pint. There are 2 cups in a pint. 3 times 2 is 6. All right, how many pints are there in a gallon? This is the trick. There are are 4 quarts in a gallon, but I don't see how many pints there are in a gallon. So students are going to have to be able to say 4 quarts is 1 gallon, and 2 pints is equal to 1 quart. So I'm going to have to do 4 times 2 to get 8 pints there. I'll show you something in just a minute that we use as a way to help out with some of this capacity, because 4th graders and adults alike seem to have a really hard time with cups, pints, and quarts, and gallons, and things like that. And then we've got weight. So we're going to have to know that there's only a couple of these for them to know. 16 ounces in a pound and 2,000 pounds in a ton. So 4 pounds is how many ounces? I need to know that there are 16 ounces in a pound, so 16 times 4 is 64 ounces. Okay, 2.5 pounds, 16 ounces in a pound, it's going to be 32. And again, the half pound is going to be half of 16 ounces. So half of 16 ounces is 8 ounces, so I'd add 32 plus 8 and get 40 ounces. Notice all of these are using multiplication, none of these use division. Sometimes in sort of random situations, students might be asked to go from a smaller unit into a larger unit. Smaller to larger numbers is division. And it's really a 5th grade skill, but occasionally it will show up just in problem solving situations. So one thing that we do sometimes to help kids with that is to make, it's called a function table. We call it sort of like a T-chart. So this is a way of showing feet and inches. And if students do this one time, they can use this for pretty much any question that's going to be given to them. So 1 foot is equal to 12 inches. 2 feet is equal to 24 inches. 3 feet is equal to 36 inches. 4 feet is equal to 48 inches. All of these are 12 times as many inches as I have feet. So if I were to say 72 inches and ask how many feet that was, instead of students having to do a division problem, they could just look here at their chart, kind of work backwards. So that might help them. And that especially helps with this, because when you're working with weight, talking about multiplying by 16, that's not a number that students are real comfortable with multiplying or dividing off the top of their head. So again, you can do this once, and then for any question that would be asked about pounds and ounces, you've got your reference here. And again, you could work backwards doing division if you want. So here's a couple challenge questions I have. Okay, 60 inches is how many feet? Again, this is a small unit going back to a big one. So I would have to know how many inches are in a foot, which is 12, but it's not 60 times 12. I'm not going to do 60 times 12 and end up with a large number of feet when I only had 60 inches. Inches are small, so I need more of them in order to equal something here. So again, instead of trying to go back, I just look over my chart and say, all right, well, where was 60 inches? 60 inches is equal to 5 feet. I don't have to do any division or worry about anything like that. But it is a division problem. All right, 51 inches is equal to how many feet? Again, there's 12 inches in a foot. So I'm really doing 51 divided by 12. But that doesn't work. So when I come back over here, where would 51 be? Well, 4 feet is going to be 48 inches. That leaves me with the remainder. How many are left over? So this is actually going to be 4 feet. 4 times 12 is 48. And 3 inches left over. Okay, so 4 feet 3 inches is going to be 51 inches. Okay, again, 96 ounces into pounds. So I'm taking a lot of something small and I need less of something big. So this is going to be 96 divided by 16 ounces in a pound. Again, students who aren't real comfortable with that, if they've already made their chart here and sort of skip count their way up here, I can find 96, just work backwards, 6 pounds. All right, and then 3 pounds, 4 ounces. We want to see how many total ounces that is. This is a combination problem here, or what we call a mixed measure question. So I need to know how many pounds there are in an ounce. So that's 3 times 16. If I've already made my chart, got it right there. That'd be 48 ounces plus 4 more. It's going to be 52 total ounces. I'll show you real quick one thing we teach kids about capacity. We call him the gallon man. The gallon man is something I could teach kids one time how to draw, and then it takes a few seconds to draw, but it really helps them answer any question involving capacity they'd have to do. Give him a face. He has a body. Okay, his body is equal to 1 gallon. So I have to draw him. And the first thing I'm going to draw when I draw a person is I'm going to draw their arms and legs. Okay, so I'm going to draw their arms and legs, and these are going to be my quarts. And that's not the official abbreviation for quarts, but I made him kind of small. So, so this will show me that these 4 quarts are equal to 1 gallon. Okay, well, he's only got shirt sleeves and shorts here. He actually needs the legs. So we're going to break up each one of these quarts. Gets broken up into 2 parts. Forgive me for my drawing, but this is kind of the easy way to do it. So there are, and again, all this is on the reference sheet, so I don't really have to memorize this, but once they draw it, once they get this. So there are 2 pints in a quart. Okay, so I can see how many pints there are in a quart. I can see how many pints there are in a full gallon. So 1, 2, 3, 4, 5, 6, 7, 8, or 4 times 2 is 8. That was something that was not on my reference chart before, but if I draw the gallon man, I can see that right away. Now each pint is going to be split into, he needs fingers and toes, although he doesn't have 5 of them. Each pint is split into 2 cups. I'm just going to draw those C's for cups. Okay, so now I see there are 2 cups in a pint. There's also 4 cups in a quart and 16 cups in a full gallon. So very quickly, if I were to ask, how many pints are there in a half a gallon? Okay, half a gallon would be down here. So how many pints is that? 1, 2, 3, 4. How many pints would be in 3 gallons? That'd be 3 of the gallon man. So there's 8 of them in here. 8 times 3 is 24. How many quarts would be in 2.5 gallons? 4, 8, and then 2 more makes 10. And then you could do multiplication or division very easily either way. If I said I have 8 cups would be equal to what? 8 cups is equal to 4 pints, is equal to 2 quarts, is equal to a half gallon. 3 cups. 3 cups would be, 3 cups is going to be 1.5 pints. I could work on it that way. Basically, any question you would ask involving capacity, it's very easy to see equivalence here of what's equivalent to one another, what's equivalent to a full gallon. Again, any of the things that are skipped over here, because this only goes from, well, it starts at fluid ounces too, but cups to pints to quarts to gallons, which are single progressions. But the gallon man lets you go from, cups to gallons, cups to pints, cups to quarts, pints to quarts, pints to gallons. So kids like drawing it. It's very easy for them to remember. And again, a very easy way to keep visuals of kind of the relative sizes of what's bigger and what's smaller. And, kids have no idea about the difference in a pint and a quart and how big that really is. But this kind of helps them to see 2 cups in a pint, 2 pints in a quart, 4 quarts in a gallon. So, all right, thank you for watching. I will make another video on metric units for next week. Thank you.